Now it is time to review all the factoring methods that we have gone over. So first we're going to look at the greatest common factor. So factoring with the greatest common factor means I would look at all the terms, see the greatest common factor they have in common, which in this case is 8x, and I would factor that out. I would undistribute essentially here. And so one way to check your answer is to distribute, and if I were to distribute, I would get 16x squared plus 8x, which is right where I started. And then I also check to make sure what I have in parentheses has no more common factors. It does not, so that problem is complete. So now I want to remind you the difference between this, which is an expression, and this, which is an equation. So now it's equal to something, which makes it an equation. So now instead of simply factoring, I need to solve it. So I'll start the same way. So I'm going to take the 8x, and then I get the 2x plus 1. But now, since it's set equal to something, in this case 0, which is what you want, now I factor first, and then I set each individual factor equal to 0, and solve it that way. So from the beginning I couldn't isolate x, but here I can because I've broken it into two smaller things. So here I undo multiplying by 8 by dividing by 8. X is 0 over 8, which is just 0. Remember, if 0 is in the denominator, it's undefined. The 0 in the numerator, that's okay. Over here I'll subtract 1 from both sides. I get 2x is negative 1. Divide both sides by 2. I get x is negative 1/2. And those are my two solutions. So next we looked at factoring by what was called grouping. So if I look at all four terms here, they don't all four have a common factor. So then I can try to group them. So if I group these two terms together, they have a common factor, and that would be x. So if I factor an x out here, that would give me 7x plus 6y squared. And then if I were to look at this next group here, let's see, the 14 and the 12, they have a 2 in common. Bring that plus sign down there. So they have a 2 in common, and it looks like they both have a y in common. So I factor out 2y, which was the greatest common factor of these two terms, and then that gives me 7x plus 6y squared. And so something ideal has happened here. So this is not factored. I want to point this out. This is not factored. This is that first step in factoring. I need to rewrite it. So I have the x and the positive 2y, so x plus 2y. Since they are both being distributed to the same thing, this, we are going to just write that binomial one time. This is the factored form. So this factored, this here is not yet factored. So that problem is complete. So remember also when you're grouping that you can rearrange the terms. So here I have four terms. They don't all four have a common factor. These don't have a common factor. And so what you can do is I could take my AB, then plus 4a squared b. I'm just rewriting the order. Then plus 3cd. Then the plus 12acd. And I'm not going to do this problem all the way. I'm actually going to do another grouping problem soon. But here I can see that I did just create two groups that do have common factors, and I could continue. So another factoring method we learned was called the difference of two squares. So with that one, it's one you just have to recognize. So if you have two terms here, and they are both perfect squares, and it is subtraction, it can be factored as a difference of squares. And this is like the general formula for it. and we'll look at a couple of examples. So notice 25 is a perfect square, it's 5 squared. 81 is a perfect square, it's 9 squared, and it is a difference, it is subtraction. So that's where I'm going to look at that, and I'm going to recognize that that would be 5w plus 9 times 5w minus 9. I'm following that pattern, almost like a formula. And if I were to distribute, if I were to FOIL first, outer, inner, last, I would get right back to this, which is what I would want. It would mean I did it correctly. So here again, I want to do another example where you are solving this instead. So notice I have an equal sign, so I would actually be solving for w. So the first thing you would want to do is get it equal to 0. So I would minus 81, so subtract from both sides, which would give me 25w squared minus 81 equals 0. And that's what I want. I want it to be equal to 0. So the next thing that I would have to do here is I would have to factor, which I already did above, so I'm just going to copy that down. I notice my difference of perfect squares. So I get 5w plus 9 times 5w minus 9, both equal to 0. So I would set each individual factor equal to 0 and solve. So when I do my 5w plus 9 equal to 0, subtract 9 from both sides, subtract 9 from both sides. That gives me 5w is negative 9. I would divide both sides by 5. And that gives me w is negative 9/5. That's my first answer. And if I were to solve this second one equal to 0, I would get positive 9/5. So now we're going to look at factoring trinomials, and remember prefix tri means 3, so those polynomials with 3 terms. So here's where we were reverse foiling. So the first thing you always want to do, and remember this when you're taking a test, is to look at the terms and first see if there's a common factor you can factor out. Here there's not, so I'm going to go ahead and try to reverse FOIL it here. So I think what times what would give me x squared, and the only possibility is x times x. I know this needs to be a positive times a negative to get a negative 15. And then I think of all the things I could multiply to get negative 15. So negative 5 times 3, 5 times negative 3. I could keep going, but I don't need to. I want those to combine to give me negative 2. And so I know it's going to be minus 5 plus 3. And that problem is complete. I factored it. So again, I'm going to warn you. Be careful of the difference here. So here all I could do is factor. Here it is an equation, so I need to solve it. And so the first step in solving is to get it equal to 0, which it is. So that's nice that that's done for us. Then I would factor x plus 3, and then x minus 5. Then I would set each factor equal to 0 and solve. So I'd set x plus 3 equals 0. I would set x minus 5 equal to 0. When you solve both of those, you're going to get negative 3 and positive 5. And then that would be your solution set. So this time, my solution, since it's an equation, I'm going to get numerical values like this versus binomials when I'm just factoring. Okay, so here's another one. So I'm going to do the same thing. Check for a common factor first. There's not one. I think of all the things I can multiply to give me a positive 15, but I want them to combine like terms to give me a negative. So I know it'll be a negative times a negative. So I look here, it's going to be negative 5 times negative 3. And it doesn't matter where I put the 5 and where I put the 3 since they're the same. So here, I'm done. I've factored this problem. And again, if I were asked to solve, now it's actually the same trinomial, but I'm being asked to solve it. So the first thing I'd want to do is I'd want to get it equal to 0, and that would require me to add 15 to both sides, so that this would be 0. So then I get x squared minus 8x plus 15 equals 0. And so the next step I would take once I get it equal to 0 is to factor it, which we did. I'm just going to kind of take a shortcut. I did up here. So I have x minus 5, x minus 3 equals 0. So I'm going to look at those binomials and individually set those factors equal to 0. So I would factor it, set the factors equal to 0, and so I will get two solutions. I'm going to get 3 and 5. Okay, and so I also wanted to show you this in case it comes up. If you were asked to find the roots, that is the equivalent of asking you to solve, which we have just done for like 2 or 3 problems in a row. And another way that that can be worded is find the zeros, which again is just asking you to solve. So I'll go ahead and do this one, but if you're asked find the zeros or find the roots of the quadratic, it's asking you to solve. And remember, when we solve, we first have to get it equal to 0. So I subtract that 20 so that I get a 0 over here. Then I check for a common factor. There's not one. So I'm going to factor that. I'll do it more quickly than I have been here. So I get x plus 5, x minus 4. Set each factor equal to 0. And when I do that, I'm going to get negative 5 and positive 4. Okay, so now I want to do a couple of examples where we're factoring a trinomial, but when the leading coefficient is not 1. So here the leading coefficient was 1, leading coefficient was 1, and so forth. The leading coefficient was 1, so those are going to be easier than when you have a different leading coefficient. And the method I taught for this was to create a grouping problem. So the first thing I would do, and sometimes this will work out well for you and sometimes not, but the first thing you always want to do is check to see if there's a common factor. And in this case, there is. That 5 will factor out. So here, if I factor out a 5, I would get v squared minus 6v plus 8. And so I do not have to do a grouping method here. I'm going to be able to factor that just like I was the previous problems. So when the leading coefficient isn't 1, your first thing you want to try is see if you could factor something out, a greatest common factor. Here I could, so now I'm just going to keep the 5. Can't get rid of the 5, but now I'm going to factor this. So when I factor that, that is going to give me, let's see, v minus 4 and v minus 2. And again, it's an equation, so I need to solve it. 5 equal to 0, not going to happen. That doesn't make sense. 5 can't equal 0. If that were a v, then yes, that would be a solution. But 5 equals 0 doesn't make sense. This will give me 4. This is going to give me 2. So I get my 4 and my 2. So it's not always going to work out so well and convenient that that leading coefficient factors out. So we'll look at an example here, like where we have a 4. So the first thing I'm going to do is get it equal to 0. So I'm going to get 4n squared minus 17n. I'm going to add the 4 to both sides to get it equal to 0. So in this case, the leading coefficient does not factor out. So I'm going to create a grouping situation here. So what you do is you take that 4 and you multiply it by the constant, that last term there, which is not always a constant, but in this case it is. So then I get a 16. So I'm going to think about all the factors of, let's see, 16, things I can multiply to get 16 that would combine like terms to give me negative 17. So right off the bat here, I'm thinking negative 16 times negative 1. So those multiply to give me positive 16. They'll combine like terms to give me negative 17. So what I'm going to do here is I'm going to rewrite this trinomial, 4n squared. But this middle term, negative 17n, I'm going to rewrite it. I'm going to rewrite it as minus 16n minus 1n. Now notice it's still equivalent. It's the same value. But now I can factor this by grouping. So when I look here, these two terms have a common factor, and that would be 4n. So when I factor out that 4n, I get times n minus 4 here. I need to bring down that sign in the middle, that minus, so that I don't forget. And when I look here, upon first inspection, it looks like these don't have a common factor, but they do. I could say they have a common factor of 1. So if I were to factor out a negative 1, so I would be like thinking negative 1 distributed to what gets me back to here. And so that would be n minus 4. And you might take a second to think, but if I were to distribute, I would get negative 1n plus 4, which is what I have right there above. So this is still not factored. So this right here, there's a common mistake people make, and they think that this is it, this is their answer, but that is not the factored form. So I need to rewrite this. I'm going to put my n minus 4 together just once. And then I'm going to combine that 4n minus 1. And still I am not finished, because in this particular example I was asked to solve it. This is an equation. I've got an equal sign. So I'm going to set each factor equal to 0. So here's my factored form. So this is going to give me n equals 4 when I set this equal to 0 and solve. And then here I will get positive 1/4. I think we'll do one last example here. So here I just wanted to show you an extra tricky thing is just, again, another reminder to first check for a common factor. So in this example, I notice they all have a 3 in common. So if I factor out that 3, so I factor out the 3. Now it still needs to be factored, but just a reminder to always check for that common factor first. So here you might want to pause it, try it, factor it by grouping, and see if you get this. So when you finish factoring that, you should get this. When you set each factor equal to 0, you get negative 1/3 and negative 7.